Techniques for improving air movement. Without using any mechanical devices, some air movement will occur through natural convection. Warmer air is less dense than cold air, hence warm air rises and cold air sinks, which can lead to vertical temperature gradients in the glasshouse. Relying solely on natural convection to drive air movement is unlikely to result in a homogeneous climate. This video considers some traditional and alternative methods of air movement and their relative merits. There are various reasons for temperature differences to arise in a glasshouse, such as pipe heating, incoming radiation from the sun, outgoing radiation, i.e. heat loss from the glasshouse, or transpiration from the crop. Some growers use pipe heating to create convection currents. For those with grow pipes or rail heating, the warm air will rise through the crop and can help to carry moisture away from the plant, locally reducing relative humidity. However, this can be an expensive method of generating air movement, especially if the heat isn't required. Relying on convection to stimulate sufficient air movement to keep the climate active and homogeneous is not advisable. Instead, air movement through the use of fans is much more effective. A range of fan setups are available, although the suitability of each will depend on the type of crop. An important consideration should be the height at which the air moves and how this interacts with the crop. A horizontal fan setup can be regarded as the conventional option for generating air movement. These fans tend to be mounted above the crop and operate by moving air in a horizontal plane to create a circulation pattern. This can be a good option for a tall crop as it will stimulate airflow through the plants, but it may not be the most effective solution for ornamentals at ground level. As a rule of thumb, aim to recirculate the total volume of glasshouse air twice per hour using around 20 fans per hectare. Use the fan specification sheet to determine if it's up to the job. Instead of moving air across the greenhouse horizontally, which can result in layers of air moving at different speeds, a vertical setup can be a better option for making sure air penetrates the crop. In addition, air is moved a shorter distance, meaning a lower power fan can usually be used. A ducted system consisting of a fan at the top of a long plastic tube which directs air towards the ground could be a good option for bench crops. However, the blown air can stir up dust on the ground and can result in localized air movement, which may have an adverse effect on the ground crop by stimulating too much evaporation, thus drying out the plant. Horticulture-specific vertical fan designs, such as the nivelator, disperse air in a conical flow, giving a wide range of coverage. Air is drawn from both above and below the fan, creating a local circulation pattern. Depending on the height at which the fan is mounted, each unit can cover a diameter of around 15 meters. While this can mean more fans are required, the aim should always be to deploy the most effective solution to promote air movement for any given crop. Another option is to use long plastic tubes, incorporating a fan underneath the crop. The tubes have holes along their length, allowing air to escape, resulting in some air movement around the tubes. However, the nature of the design usually means a fan at one end of the tube, which can lead to unevenness in airflow horizontally out of the perforations in the tube. The theory of where air should go based on a particular layout or manufacturer's claims does not always match up with reality. Factors such as wind direction or the slope of a glasshouse can significantly affect the airflow. It can be a good idea, therefore, to visualize how the air is moving. One effective method is a smoke test. This can often highlight otherwise unseen influences, meaning problems can be identified and remedied, which could be as simple as adjusting fan positioning. Another option is to use a proxy measurement, such as temperature. This is covered in video number 2. Good air movement is a vital part of creating a homogeneous climate, which can help improve crop quality. While there are various methods for generating air movement, consideration should be given to the most effective solution for a given crop and glasshouse layout. Fans are often the most economical solution and can reduce energy consumption compared to using pipe heating. The layout and number of fans should be carefully planned. Be prepared to test and adjust the configuration, for example using a smoke machine or a matrix of temperature sensors to ensure optimum results. In the other 2 videos in this series, we explore Video 1, what can air movement do for you? And Video 2, is the air movement in your glasshouse effective? For more information on optimizing your production environment, visit growsave.co.uk.